Alright, so in this video I would like to talk about two different ways of thinking about electric fields. We've kind of seen both of these, but I want to make them a little more explicit. Okay, so our first model for electric fields was the motivation that we had for doing it. Okay, so model one is basically just that we observe that forces are kind of a pain to calculate. So because of that, because we have to worry about all of the pairs, for instance, and we have to worry about the components, and we have to worry about superposition, etc. It's kind of nice to think maybe there's some sort of strategy we can use to make that a little bit easier. So the idea here is that we just calculate the electric field, which is the force divided by the test charge. Okay, and so when we do that for one test charge, that's going to be k q1 over r squared r hat. And notice then we don't have to worry about the pairs. It's just a little bit easier. We consider the particles one at a time. Okay, so by considering the charges one at a time, we simplify the math just a little bit. Okay, it's not a huge benefit, but it helps a little bit. Okay. So this was the first way that we thought about electric fields, and that is where the definition comes from. But after drawing out electric fields near some charges, we started to see that there was a structure to them. Okay, so that's going to go into our second model for electric fields. Okay, so the second model is that there is an invisible structure near electric charges. That tells us what the forces will be. Okay, so instead of thinking of this as just a mathematical trick, we can think of this structure as having some real existence by its own right. Okay, so we can think of this even as being the agent by which charges influence each other. Okay, so to take that even a step further, a question that we sometimes shy away from is, well, how do the charges know? If you have two positive charges that are some distance apart, they experience a force, each one pushes on the other. How do they know? They're not actually touching each other, and yet somehow they're able to push each other apart. And in some ways, the electric field is an answer to that. Well, if each charge has this invisible structure surrounding it that fills up space, then what the second charge is responding to is the presence of that structure at its location. So it's not so much that they just know each other are present, it's that they actually are sort of sending out these fingers that fill up all of space, and they're able to push or pull on each other based on those that structure. Okay, so at this point, it's not really clear whether either of these two models makes sense, whether one is better than the other. But it turns out that they're both reasonable. So it's not going to be the case that either one is totally wrong. And in fact, what we're going to find a little bit later is that Model 2 is going to be critical to understanding certain phenomena. So later, um, Model 2 will be essential. Okay, and what I mean by that is there are going to be certain things that we cannot explain without thinking about the electric field. Our physical models for instance, light, rely on electric fields that do not have charges present. Okay, so electric fields are going to be a thing that have a reality. They have a presence even in the absence of this Coulomb's law situation where we came up with them in the first place.